Okay, we can use the ideal gas equation to calculate the MR of gases and of volatile liquids. Let's see how we can do that. Well, we've got our ideal gas equation there on the left. PV is equal to nRT, and don't forget to be careful with the units. Careful with the units. PV is equal to nRT, and we also know that right, N, the number of moles, is equal to mass over mR. So let's put that into our ideal gas equation, and we get PV is equal to mass RT over mR. So we rearrange that to get mR subject, and we will get we get mass times R times T divided by P over V. So let's do, we've got a gas here, and this gas X, 1,000 centimeters cubed of gas X has a mass of 1.80 grams. So if what they're essentially telling us here is the density of the gas, isn't it? It's 1.8 grams per 1,000 centimeters cubed. So in other words, we usually measure the density in units of gram per centimeter cubed. So that's going to be 1.8 times 10 to the minus 3 gram per centimeters cubed. Density, you normally use that little symbol, rho. Okay, so if you know the density of a gas, you can work out its MR. And if you just have a little think about that, so if you've got a very heavy gas, that means it's going to have the mass over the volume is going to be big. Yeah, the mass over the volume is going to be big, so that means it's got a big MR. And we know that's true. Gases like carbon dioxide, quite a big MR, 44. It's heavy. Gas like hydrogen, MR, atomic mass of MR, because it's a molecule of 2, it's going to be very low density. So we kind of know that already. Helium, density of 4, an MR of 4, pretty low density gas, and balloons will float with it. Okay, so let's do this. Let's find out what this gas is then. Let's find out the MR, put the numbers in. Right, so we've got MR is equal to 1.8 grams times 8.31 times, what's it, 298 Kelvin, we'll say. Standard temperature and pressure, 101.3 times 10 to the 3 pascals, not pascals. And the volume they tell us is 1,000 centimeters cubed. So divide by a million to give you meters cubed. That is 1 times 10 to the minus 3 meters cubed. So 1 times 10 to the minus 3 meters cubed. Put all that in there. The MR is 44. I think you work all that out. And that means the gas is probably, can't even spell probably, but you know what I mean. It's probably CO2, or actually it could be propane, which is also C3, C3H8, that's 44. And I think the other one, I think it's N2O, 28 plus 16, yeah, that's 44 as well. All of those three are all 44. Okay, so let's just have a look at this little apparatus here. You can use this to find out the MR of not just gases, but if you've got a volatile liquid. So in a volatile liquid, which means one with a low boiling point. So a lot of organic, suitable for finding the MR of organics. So what you do is, you have this black syringe is a gas syringe. And it's in this blue box, and which is see-through, and that's full of steam, and that means it's at high temperature. So we're going to get some liquid here, and we're going to inject it. There's a little rubber seal there on the end, a little rubber seal there, and you can inject your volatile liquid through. Once it gets in there, because it's hot, it will turn into a gas, and it will move the plunger backwards and you can measure the volume of it. Now you need to know the mass of your volatile liquid added. So that's what you do is you've got this little syringe here. You weigh that when it's full up to start with, then you weigh it when you've injected stuff into the gas syringe afterwards and subtract it to get the mass. So here's an experiment here. The mass of liquid injected was 0.1 gram. We're using standard pressure. The temperature with the thermometer, which is up here, you measured was 100 degrees C. That's 373 Kelvin. And when the plunger moved backwards, it stopped at a volume of 67 centimeters cubed. So we need to put that into our ideal gas equation. Well, to find out the MR, let's use this. So MR, mass RT over PV. MR is equal to mass RT over PV. Let's put the numbers in. Mass 0.10, 8.31, temperature 373 Kelvin, divided by the pressure 101.3 times 10 to the 3 pascals. And the volume, well, the volume 67 centimeters, so cube, that's convert to meters, cube divided by a million, 67 over 10 to the 6. Let's work out what the MR of that gas is then. Okay. .67 is the MR. So as I say, 46. That volatile liquid, it could be ethanol. That's got an MR of 46. So just a couple of ways in which you can use the ideal gas equation to find out for useful purposes. Yeah. Okay.